Okay, so before we can get into finishing the rest of filling in the unit circle, we have to remember what our special right triangles are. So we're going to review what 45, 45, 90 triangles look like and what 30, 60, 90 triangles look like. And you should have learned about these in geometry and possibly in algebra 2. So we know, of course, that our a squared plus b squared equals c squared formula, our Pythagorean theorem, is always true for right triangles. So we're going to use our brains and common sense to kind of think our way through this. So if we have two 45-degree angles, these angles have to be equal, which means their sides also have to be equal. So we're going to set those side lengths as x. So now if we work our way through, we know that x squared, one side squared, plus the other side squared, which is also x, should equal c squared, our hypotenuse. We don't know what that is. So we have x squared plus x squared equals c squared. So we have 2x squared equals c squared. So we want to solve for c squared. So we want to solve for c. So we're going to take the square root of both sides. So we're going to get c equals the square root of 2x squared. Now, we know that the square root of x squared is just x, so that tells us that c is equal to x times the square root of 2. So for a 45, 45, 90 triangle, whatever the lengths of the short sides are, the hypotenuse is just the length of the short side times the square root of 2. So now whenever you're doing your triangle ratios, like in 30, 60, 90, you want to start off with the smallest side. So the smallest side has to be across from this 30-degree angle. So I'm going to label that as x. So now the way it works out is that the side across from 60, so this is our short side, we have our long side and our hypotenuse. The long side of a 30, 60, 90 is always the short side times the square root of 3, and the hypotenuse is always 2 times the short side. So those are ratios that you just have to learn, and so you hopefully learn them in geometry. So we're going to go about using them in real triangles to show you how they work. So we're going to start with 45, 45, 90 first. So in this case, we're solving for the hypotenuse. I'm just going to cross off the x so it doesn't confuse us. So we know that these two sides are equal, and we just saw on the previous slide that the formula for the hypotenuse is the short side times root 2. So we have side times root 2. So that tells us that this is x, this is x, this is x root 2. Well, if x and 5 are on the same side, x is equal to 5, so that tells me the hypotenuse is equal to 5 times the square root of 2. So looking at number 2, we have the opposite case. We know that the hypotenuse, so the formula on the hypotenuse is normally x times the square root of 2, and we can see that on our English, hard, whatever. So we have on our hypotenuse, the label is 16 times the square root of 2. So I'm going to set those two things equal to each other. And we want to solve for x, because that x value stands for the length of the sides of the legs. So if I divide both sides by the square root of 2, it cancels out on both sides. And we're left with x is equal to 16. So each side of this 45, 45, 90 triangle must be 16 units. So we're going to do the same thing down here. So again, this is our right angle. So our hypotenuse is equal to x square root of 2. And we need to solve backwards. So we're going to set x square root of 2 equal to 12. Okay. So to get rid of the square root, you have to divide both sides by the square root of 2. So we get that x is equal to 12 over the square root of 2. But we know that we can't leave a square root in the denominator of a fraction, so we're going to rationalize it. So what we're going to do is we're going to multiply the top and the bottom of this fraction by the square root of 2. Because when we do that, the square root of 2 times another square root of 2 cancels out and gives me a regular 2. Then I have 12 square root of 2 in the top, and 12 divided by the 2 in the bottom would give me 6. So I have 6 square root of 2. So that tells me both of the legs of this right triangle are 6 square root of 2. Okay, on to 30, 60, 90s. So for 30, 60, 90s, remember the short side is across from 30, so this must be our 60-degree angle. So this is our x root 3, and our 2x. Well, if the short side is equal to 8, the long side is equal to 8 times the square root of 3, and the hypotenuse is 2 times the short side, so 2 times 8, which is going to equal 16. So now over here, here's our 30-degree angle. So we have the long side, and we know the long side from our formulas is equal to x times the square root of 3. So we're going to set 5 root 3 equal to x square root of 3. Divide both sides by the square root of 3 to get x. So x is equal to 5. So that tells us the short side of this triangle is equal to 5, and the hypotenuse is 2 times the short side, which is equal to 10. Okay, so now working backwards from the hypotenuse. We know the hypotenuse is equal to 2x. So 2 times the short side. So we set 16 equal to 2x. If we divide by 2, x is equal to 8. So that means the short side of our triangle is 8. So there's our 30-degree angle, so our short side is across from it, so the 8 is going to go here. And then the long side is always x times the square root of 3. So this becomes 8 times the square root of 3. So there was a short little review of special right triangles. You have a few OYO questions to do on the back of your worksheet. So give it your best shot, and we'll see you in class.